Hello everybody and welcome back to another video on my channel. Today we will be talking about another very important test, which is the alternating series test. Now, the biggest reason why this is so incredibly important is because it deals with such a wide class of series that it becomes very essential to solve most series, as not every series is going to have all positive terms, and this is very also useful for stuff like harmonic analysis, etc., etc. So, today we will be talking about that, and without further ado, let's move on to the video. Also, my fault if there's any background noise or anything. I try to minimize as much as I can, but sometimes I can't. So, what is an alternating series? Well, we talked about this in a previous video, but to recap, an alternating series is of the form this. Essentially, -1 to the power of n times b of n. Because as n goes from 0 to infinity, n goes through 1, which makes it negative, then 2, which makes it positive, then 3, which makes it negative, and so on, and so on, and so on, until infinity. But what's more important right now is that basically what it can do right now is series that would not normally converge. When you add this term, it does converge because this -1, this negative and positive adding up, creates some very, very crucial cancellation. So, how would we know if they converge? Well, there are three main things. Number one, that this term, b of n, is greater than 0. Now, that's just very simple. Most series will have that. And the reason is if it's less than 0, then you'll most likely have to adjust the series, although this is very trivial. The second one is much more important, though. It's that b of n has to be greater than b of n plus 1. Basically, that means every term has to be greater than all the ones after it, or every term has to be less than all the terms before it. And number 3, what we have is the limit as n approaches infinity of b of n is equal to 0. That means this term over here has to approach 0 as n approaches to infinity. Now, if you remember, we talked about the harmonic series in a previous video and how this diverges. But if you have the same thing, but instead you have an alternating harmonic series, this actually converges because this b to the n part, which is 1 by n is greater than 0. The next, every term is less than the last, so 1 by 2 is less than 1 by 3. Not less, what am I saying? Greater than 1 by 3 is greater than 1 by 4, and so on. And 1 by infinity, which is the limit, is 0. So, in fact, all of these conditions are met, so the alternating harmonic series converges, but the regular one doesn't. Also, this video, I'm going to introduce you to something else, and that is called the different types of convergence. Now, basically, there's another test, but it's basically within the alternating series test, and it's not really that crazy. It's pretty much introduced with the alternating series test, so I thought there's no point of making another video. So here we go. What it is essentially is you have, let's say we have an alternating series equal to 0 to infinity, -1 to the n plus 1, b of n. Now, essentially, what happens is this series over here, this series, if it satisfies all three of these, is a convergent series, okay? It converges. But, let's say we have the term let's say if n is equal to 0 to infinity of just b to the n converges, then it is called absolute convergence. Basically, absolute convergence. Since if this is convergent, b of n, then of course -1 to the n plus 1 b of n, where it's alternating, so there's even more cancellation, will converge. But If it does not, like else, then it is conditionally convergent. And since it's not conditionally convergent, just means that the regular thing does not converge, but the actual series, the alternating series, does converge. One example of conditionally convergent series is the alternating harmonic series, because 1 by n doesn't converge, but the alternating one does. And one thing special is pretty much this stuff only applies to alternating series, thus another reason I chose to keep it in this video. So that seems to me about it. Thank you so much for watching this video. See you in the next one, and bye-bye.